Hello, Math 2 students. So today we're going to go over the 3.5 Day 2 Notes extension, and we're going to kind of delve deeper into different ways to solve quadratic functions. So far we've really focused in on how to solve using the quadratic formula, and we've kind of touched on two other methods as well, which is factoring, setting equal to 0 and solving, and then there is also the completing the square method. So we're going to try those out today. All right, so it says find the following information for each quadratic function. So first it says, does this factor? If so, factor it. So let's try and remember what factoring is, right? When we factor something, we got to figure out, this is a trinomial, we got to figure out what multiplies to give us 8 and adds to give us a 6. So the two factors that are going to work here are going to be 4 and 2. So if we were to factor this, we would get x plus 4 and x plus 2. All right. So now, if you recall, when we're trying to find the x-intercepts, that's what they ask for next. When you try to find the x-intercepts, remember, you have to set this function equal to 0. And then when you do that, you set each of the factors equal to 0. So you get x plus 4 equals 0 and x plus 2 equals 0. This should look pretty familiar. And then you bring the 4 over and you get x equals negative 4. You bring the 2 over and you get x equals negative 2. So then your x-intercepts here would be negative 4, 0, and negative 2, 0. That should be kind of a refresher from last module. So now it asks for it in vertex form. So this is, again, going back to module 2 here. We've got something in standard form, and they're asking for it in vertex form. Well, how do we go from standard to vertex form? Well, we complete the square. So that's what we need to do here. So we have x squared plus 6x plus 8. So we're going to write it like this. We've got x squared plus 6x, and then we're going to write plus 8 on the outside here. So to complete the square, we take the guy in the middle, which is a 6, divide it by 2, and square it, which is going to give us a 3 squared, which is going to be a 9. And again, there wasn't any leading coefficient here, so we added in a 9. We just subtract out a 9. So now we have to write this guy as a perfect square. So we're going to do x. And then to figure out what number goes there, you take this guy and divide by 2. So it's a positive 6 divided by 2. It's going to give us a positive 3. You square it, combine these guys, and you get a negative 1. So that is your vertex form, right? We've got, x plus 3 squared minus 1. That would be our vertex form. So then it asks for the vertex, right? So the vertex here is going to be negative 3, negative 1, all right? And then it says, what's the line of symmetry there? Well, this line of symmetry is going to be x equals negative 3, okay? All right, and I think what they're trying to do here with the distance from line of symmetry, well, they're saying, well, how far? They're referring to your x-intercepts here. So it's saying, well, how far is negative 4 from negative 3? How far is negative 2 from negative 3? So if we look here, right, we've got negative 4 and negative 2. So let's just draw our axis here. We've got negative 4, negative 2, and then we've got our negative 3 right there in the middle. Well, how far is the line of symmetry from those two x-intercepts? Well, they're both 1 away, right? Negative 4 is 1 away from negative 3. Negative 3 is 1 away from negative 2. All right. Now it says solve using the quadratic formula. So let's go ahead. We're going to solve this using the quadratic formula. We've got x squared plus 6x plus 8. We've got a equals 1, b equals 6, and c equals 8. So now we're going to go ahead and plug it in. So we've got negative 6 plus or minus the square root of b squared, which is 36, minus 4 times our a value, which is 1, times our c value, which is 8. So go ahead, plug this into your calculator. Tell me what you get inside of the radical when you plug this into your calculator. Plug in 36 minus 4 times 1 times 8. All right, when I do it, I get a 4. Oh, and I forgot, we got to do all over 2a, right? So we've got negative 6 plus or minus root 4 all over 2. And we all know that the square root of 4 is equal to 2, so we can replace the root 4 with a 2. And we get negative 6 plus or minus 2 all over 2, which would give us a negative 4 over 2. Well, actually, here, let me rewrite it this way so it's less confusing. We could split that up, and we get negative 6 plus 2 over 2, and negative 6 minus 2 all over 2, which is going to give us a negative 4 over 2, which would be negative 2. And then this would give us a negative 8 over 2, which is going to be negative 4. Okay, so let's think about, we just got 2 and 4 as our solutions. Interesting, right? Negative 2 and negative 4 were our x-intercepts. Remember how when I talked about finding the x-intercepts, finding the solutions, finding the roots, they're all the same thing. So when we're using the quadratic formula, we're finding the x-intercepts. All right. Now, I do want to try and solve using another method. Okay, so we're going to solve by completing the square, which we've already completed the square. So now we're going to solve. Okay, so we've got this x plus 3 squared minus 1. This was our vertex form. So we can just set that equal to 0 and solve. So we would go ahead and add 1. So we get x plus 3 squared equals 1. We're going to take the square root. We're going to do plus or minus. I am running out of space. Sorry about that. All right, so we get plus or minus 1. We get x plus 3 equals plus or minus. We all know the square root of 1 is 1, so we get plus or minus 1. We got to bring the 3 over. So we get x equals negative 3 plus or minus 1, which we could split up here, right? We get negative 3 plus 1, negative 3 minus 1. We get negative 2, and we get negative 4. So look, we have now gotten negative 2 and negative 4 in 3 different ways. We got it from finding the x-intercepts, from using the quadratic formula down here, and then also completing the square and solving for x. So there are 3 different methods we can use. So observations, you could say there are 3 different methods we can use to solve. All right, and we'll go ahead and graph real quick. So we've got negative 4, 1, 2, 3, 4, negative 2, and then here. So this would be our parabola there. All right. Now, I want to point out, we're going to find out that sometimes one method is better than the other. Sometimes you can't factor. Sometimes you can't complete the square, and we're going to find that out. So if we look here, we're trying to figure out what multiplies to give us a 2 and adds to give us a negative 8. Well, guess what? That doesn't factor. There's nothing that's going to multiply to give us a positive 2 and add to give us a negative 8, because the only factors of 2 are going to be 2 and 1 or negative 2 and negative 1. So obviously aren't adding to 8, so no, it does not factor. Well, then how would we find the x-intercepts, right? Well, we know of 2 other methods we can use to solve, right? We can complete the square, or we can use quadratic formula. So let's go ahead. We're going to use both, of course. So let's go ahead. We'll do completing the square first. So we're going to go ahead. We've got x squared minus 8 plus 2. We need to rewrite it like this. We get x squared minus 8, and then we do the plus 8x on the outside. And then we're going to do negative 8 divided by 2 and square it, which would give us a negative 4 squared, which gives us a positive 16. So we added in 16. Now we need to subtract out 16. We're going to get x minus 4 squared, right? Because we take our middle term, divide by 2. We've got 2 minus 16, which is going to give us a negative 14. So now we've completed the square. We got our vertex form, right? That's our x minus 4 squared minus 14. So now we're going to solve by completing the square. I'm going to do that in red. Okay, so to solve by completing the square when you are in vertex form, you set it equal to 0 and solve. So you're going to get plus 14. So you get x minus 4 squared equals 14. You take the square root of both sides, add plus minus. So you end up with x minus 4 equals plus minus root 14. And root 14, you actually cannot simplify. The only factors are 2 and 7, and there are no perfect squares that go into it, so it's just going to stay as root 14. You add 4, and you get x equals plus minus, x equals 4 plus minus root 14. So your solutions here would be x equals 4 plus root 14, x equals 4 minus root 14. Then we'll go ahead, let's go answer these other questions. We now have our solutions here though, right? Our vertex is going to be 4, negative 14. We get that from the vertex form. The axis of symmetry is going to be x equals 4. And don't worry about this distance here. So based on our solutions here from completing the square and solving, we can write our x-intercepts. Our x-intercepts are going to be 4 plus root 14, comma 0, and 4 minus root 14. Oh boy, I'm running out of space. Sorry. All right. 4 minus root 14, comma 0. Those are going to be your two x-intercepts. Now, let's go ahead again. We're going to try and use the quadratic formula. We're going to use our second method. So keep in mind here, only 2 methods worked. We weren't able to factor, so we were able to complete the square, though. And now we're going to use quadratic formula. And I will tell you that quadratic formula will always work to solve. All right? So just keep that in mind, too. It's a little old faithful. All right, so the quadratic formula, we've got a equals 1, b equals negative 8, and c equals 2. All right, so now we're going to go ahead and plug that in. So we get 8, right opposite of b, plus or minus the square root of b squared, which is 64, times 4, times your a value, times your c value, all over 2 times your a value. So we'll go ahead here, plug this in. We end up with 8 plus or minus, and then 64 minus 4 times 1 times 2 is going to give us 56. So we get plus or minus root 56 all over 2. So now we got to break down root 56. All right. Go ahead, tell me how you would break down root 56. So when I break down root 56, I'm going to use a 4 and a 14, which is going to give me 2 root 14. That should be your final answer there. So then you end up with 8 plus or minus 2 root 14 all over 2. And of course, now we got to simplify. We're going to factor out of these two terms. So we get 4 plus or minus root 14 all over 2. Cancel these guys out. You get 4 plus or minus root 14. Now again, notice how we got the same answers using a different method, right? This method we just used was quadratic formula.